This live? So I'm just going to tell a story. It's not part of the talk. So ShmooCon is a local con in Washington, D.C., and they wanted to encourage feedback on the speakers or for the speakers. A lot of times people are hesitant to sort of raise their hand or call a speaker and say, you're wrong. You don't know what you're talking about. Get off the stage, right? So they basically, at the first ShmooCon, which was about 6 or 7 years ago, they gave everyone one of those squeeze balls, the stress balls, right? So they called it a shmoo ball. And your goal with the shmoo ball was to yell bullshit, right? And it was like you just threw it at the speaker, right? So basically they wanted to say, look, we want instant feedback, right? We want, when the speaker says something wrong, we want to know it right away, right? Like literally, wham, here you go, right? I think you're wrong. And so this kind of got upgraded because we're hackers, right? This is what we do. So over a period of years, right, the throw a shmoo ball up on stage became fire a shmoo ball up on stage. Eventually, about 5 or 6 years in, somebody had modified a leaf blower with a PVC tube. So it was backpack fired, backpack carried and fired. It made quite a sound, and they had modified a water cooler, these big plastic water cooler tubes, right, to sort of load it up with shmoo balls. So it was rapid firing at quite significant velocity, these shmoo balls at the speakers. So as opposed to giving them, where are my glasses? Do you have my glasses? Right here. I thought they were. So as opposed to giving them, glasses because of the we're going to fire Nerf darts at them, right? The speakers were given shields, right? These plexiglass shields that they had to wear. The speakers were running around like this while these guys would come running in down the hall and firing these shmoo balls at them. At which point in time, Bruce and Heidi Potter, who run the con, goes like, "Well, clearly this has gotten a little bit out of control," So they went to this paddle. The next year was a paddle. It was like a little whiteboard on like an auctioneer's paddle, so you could kind of write down, your question or hold up your paddle. And the hackers were like, F this noise. Bring back the shmoo ball. So last year they went back to the shmoo ball again. I was thinking, it's like the speakers needed some sort of a defensive system, something like a chaff, which would, notice an incoming shmoo ball, right, and fire up this thing, sort of deflect it a little bit so you'd be harder to hit the speaker. You'd give them sort of a fighting advantage. But anyway, so there you go. Are we time to go? Are we ready to start?
He wants to start.
Oh, you're going to start with a thing? You can take that one? Thank
you. Too close. I should say my first con talk was actually at ShmooCon 5, and it was the first morning I didn't know anything about ShmooCon, and Bruce Potter came on to introduce us carrying the riot shield, and I was like, what have I got myself into? And he explains the concept, and as he gets off stage, it's like, I'll just leave this here. So a quick announcement, I'm staying right in the projector, I'm going to stand away from that. Couple of quick announcements. One is there are some goodies to be given away at the end of the con tomorrow afternoon. You've got to stick around till right at the end, I think, to pick them up. But rather than throwing them out into the crowd, because some of them are potentially dangerous in terms of you don't want them thrown at you. Not quite that dangerous, but sharp and pointy. We're going to do it by raffle, and the way you get a raffle ticket is by filling in a feedback form, which I've forgotten to bring up on stage. So it looks like this, and it has all the talks listed, and you can leave feedback against any of the talks, and when you hand one of these into registration upstairs, they will give you a raffle ticket. There's also a feedback form separate to this, just about the con in general, and just to say, like, we can't make the thing better unless you tell us what's wrong and you want improving. So if there's anything you think is wrong, it's really useful to have the feedback. It's completely anonymous. Unless you win a prize in the raffle, I guess. Oh, it's not anonymous. But you can not write your own name on there. Write someone else's name. And there's a nice box for additional feedback, so anything you want to write is really, really helpful, and it helps us make the thing better next year. The other thing is, if anyone's taking part in the CTF competition, denial of service is not valid, and you will lose points. And if you know anyone taking part in the CTF competition, remind them that denial of service is not valid. You will lose points. So the leading team has just been docked some points, I think, for exactly that. I don't know. Is anyone taking part in it? Then none of you care. All right, I'll leave these two guys, excellent speakers, to introduce themselves and get on.
Thank you.
All right.
All right, so this mic is on now, right? Thank you. All right. So who am I? So I'm Bob Weiss, PWCrack on Twitter. I'm a DEF CON goon. It means I'm one of the organizers or volunteer staff that work DEF CON. For those of you who haven't been to DEF CON, it's DEF CON rocks. It's this, but way bigger. So how many people do we have here at the 4-4 Con? This is about 350 of us's, right? So DEF CON's about 15,000 of us's. And things tend to get geometrically, they scale out of proportion, right, when you get that many hackers together. I'm also a senior security technician or senior security engineer at Tenacity Solutions. And we're hiring, but I don't know, for most of you, if you're in Europe, probably not interested in a company in the United States that's hiring. So to my right is Ben Gatti, Benjamin OG on Twitter, and he is an independent developer. Anything else you want to add to that?
Nothing.
Okay. Next, oh, I'm sorry. Thanks to our sponsors, right? So if you guys haven't been to the vendor area or engaged with the sponsors, just want to do a shout out to them. This con and many cons do not happen without the donations and participation of the sponsors. So a shout out to them, and as participants, go ahead and engage with some or all of them. They appreciate that. So we're going to talk about the future of authentication today, particularly adaptive authentication. So I want to make the point on the first slide. Access, getting you to your stuff, involves two different things. It involves authentication, it involves authorization. These are two different types of things. Authentication pieces, I'm going to make an assertion about who I am, and I'm going to prove that assertion. Authorization is the server saying that understands that you are allowed to access this thing as you, right? So one is, I am Bob, which I then have to prove. And the second thing is, Bob gets to this, right? Bob can get to this. So those are two different concepts. We're not really going to talk about that much about the authorization part. Access involves both of those things. We're going to talk mostly about the authentication part, proving that I'm Bob. And typically you'll hear in security and sort of the 101 class, you hear about the 3 A's. So that's authorization, authentication, and the third A is typically audit. We're not going to talk about audit at all, but I just wanted you guys to know that. You want to do that one?
Yeah. So Bob missed the keynote this morning, and I would hope that we were a bit responsive to that. One of the questions he asked was, what is the purpose of con? And so I had thought about this previously, and one of the problems in technology really is patents getting in the way of progress. Next year, the patents for 3D printing come offline in the United States. So if you're looking to buy a 3D printer, you had to wait 14 years, right? So patents can really gum up the works. And one of the roles of getting together and discussing where things are going ought to be, in my opinion, sort of laying out a safe ground field, looking forward for technologies. Because if we get up and we talk about it, we put ourselves in a position that we can use it, right? And if we don't, then somebody else can pawn us. To be responsive, I think that is a valid purpose of the con. We will discuss something I think that pushes forward into that field. And we'd like to encourage you to think about it and be really active, because I believe in crowd think. I think that crowds are smarter than individuals, and if we really put our minds to a problem, we can probably do better as a group than individuals. So the problem we pose in this talk is, how do you, on Mars, prove that you are who you are, that you want to do what you want to do with the devices, technologies, and methods that you have at your disposal right there where you are now? How can you reconfigure the technology that you have access to right there in such a way that you could do that effectively, knowing that your devices are owned? Assume that every device you touch has a rootkit. what's left standing in that environment? So we'll get back to that question, but think about it a little bit, and maybe we can have a forward discussion on that.
Right. So two more things. Definitely, please interrupt us with questions. We'd love to do this more interactively, so that's great. And second of all, part of the purpose of this talk is that you will steal all this information and go back and do something more useful with it, right? Build upon this. I think, by the way, that applies to all of the speakers, right, and all of the cons, right? Hey, we do something, you steal it and repurpose it for your own purpose and make something else out of it, right? So we hope that you'll all continue to do that. All right, so where are we? So authentication, again, is this assertion, right? Basically, I'm making an assertion. I am Bob. Server wants to know, or other side wants to know, prove it, right? And I'm going to go through a process of providing some credentials to that system that it recognizes may only be from Bob, that only Bob would be able to do. And if those credentials are high enough quality, I'm Bob. And therefore, obviously, when we're talking about that, right, the process of how you create those credentials, how I am enrolled in the system, how I'm created, is going to play a factor there, right? So, how we told the server who Bob is, right, is a factor, is a piece of this authentication. Go ahead. So typically the easiest way to do this is usernames and passwords, right? That's what everyone's familiar with, and everyone is sort of understands how that works. The password is supposed to be this shared secret, right? It's shared by me and the system only, right? So I'll give you an example. What is not a shared secret? When you call up your credit card company, so in the United States, you call up your credit card company and say, oh, I need to get some information. They say, no problem. What's the last 4 digits of your social security number? That is not a shared secret, right? That is not a secret.
It's a broadly shared secret.
Right. So that is not a secret between me and my credit card company, right? Because the other credit card company also knows my social security number, as does my home mortgage company, as do lots of other places, including the state of Maryland where I have my driver's license, as does my wife, et cetera, right? Lots of people know my social security number. They have a legitimate reason for knowing that. Social security number is a piece of ID. It's an identifier. It's more like a username. It is not a shared secret like a password and should not be used in that way. So the concept of a shared secret between something that I know and the server knows but nobody else does, right? That we get that, right? That would be a good way of doing authentication, and there's nothing wrong with, in principle, with the way that happens. Yet we all know passwords suck, right? Go ahead, next slide.
Robert's favorite password is too many passwords.
Right. So passwords suck, and why, right? Implementation problems, right? So I'm not going to read the whole list, but the bottom line is, as passwords are a fairly weak form of authentication because of all the problems. Keep
Nice.
going, right? So we talked about sort of credential quality, right? So we have this understanding that, well, I might present this credential, and that might have some level of quality, and I might present this other credential, and that might be of a higher quality. It'd be harder to fake, or maybe it's of a lower quality. It might be easier to fake, right? But these things all these things aren't necessarily the same. So that's a really terrible copy of Dana Scully's FBI card, right? I mean, that doesn't look, I hope no one thinks that would look like a real FBI card, right? So it's supposed to be sucky credentials. Go ahead. So there's lots of other types of credentials. Again, there's a list up there. I'm not going to read the slide. And each one has sort of these pluses and minuses, right? Things that make it better or harder to forge, harder to fake, harder to impersonate, or things that, so maybe it's a really strong credential, but it's really expensive to implement. Or maybe it's, hit the next slide. So we go through pluses and minuses or pros and cons for each of these different types of things. Biometrics increase security, expensive hardware, very difficult to enroll people, right? It might take me a half an hour to roll someone's fingerprints, enroll them, test the system, make sure it's all good, et cetera. Virtual token can act as an additional layer of security, but susceptible to man-in-the-middle attacks. The pluses and minuses, we get that. Go ahead. So So then you figure out, well, what if I used multiple credentials, right? What if I did this thing and this thing? And we all get this. This is sort of the base, right? So we end up with, something you know, something you have, something you are, and I can pick two of these and roll that together, and maybe I get a higher level of credentials. Each of these has problems against something you know, something you wrote down, something you have, which means something you'll lose at some point, something you are means something you can't be revoked, right? If I don't want to have my irises scanned, I can't change my irises, right? So what you end up with is sort of this concept of a level of assurance, right? I can combine multiple factors either simultaneously or sequentially in terms of the way that they're presented. It's better to simultaneously present credentials and then fail the whole operation than it is to present one, accept it, and then roll to another screen and present another one with sort of a sequential thing. That is not as strong as the system as presenting both of them at the same time, but sometimes you need to do that. Maybe because of a routing issue, you need to know where we're going before we do that. But so we end up with this concept sort of level of assurance, and different combinations or sets of credentials may be used in different ways to get to a certain level of assurance. Go ahead. So this is the NIST slide from NIST 863.1, which basically says if I have this group of credentials down the left combined with any of those credentials, which is the same set right on the right, I can end up with level of assurance 2, which is not so good. For instance, a username and password by itself up in the upper left is a level 2, right, by itself.
So for the challenge later, notice that the only things that are 4s are the things that include the OTP device and the cryptographic device. Software cryptographic token is only a 3, regardless of how it's combined, right? So the answer we're looking for has to satisfy this highest level of assurance.
Right. So, and no reason why it had to be in 4 categories, no magic number. This is, NIST made a decision, and that's what NIST is, the United States National Institute of Standards. That's what they do, right? They make decisions about how we're going to categorize and create standards. So this is their list, but again, there's no magic here. No reason why you couldn't add some other factors down the list or divide it up in a different way. So the problem with multi-factor is it gets broken, right? How'd they do that, right? So typically, multi-factor is not as secure as you'd think. You think, so you're working in the enterprise and we're going to implement multi-factor. Well, we should be good now, right? Now we've got, we've got a 2048-bit key. So the basic 2 things that are happening in all of this stuff, right? Why two-factor authentication won't stop the hacking crisis, this and that, all these different bank accounts is, there's basically two ways I do it. I can own both devices, right? Or I can wait for you on one device. I'm on your desktop. I've owned your desktop as a for instance. Wait for you to get your second factor of authentication, create a session out to your bank, and then I just piggyback on that session or hijack that session. So, so effectively, the other way to go is a man in the middle, right? I can man in the middle both of the factors, at which point
I think you can fish them both as well.
Absolutely, right? So, you've gotten to a higher level of assurance, but you have not solved the problem, right? If we assume that I might still be on one or more of your devices, which is a pretty good assumption, right, for anyone working today in information security, two-factor authentication is not the answer that we were looking for. Go ahead. So this is something Ben said on the phone, I guess about a week ago or something like that. If you're using more authentication to solve an authentication issue.
This is an axe keyom.
Right. I interrupted and I was like, you're doing it wrong, right?
What is an axe keyom? You going to help us with that? I don't know.
So
it was late.
Yeah. So we're jet lagged. We're late. Whatever.
2 beers, I think, spelling right there.
So yeah. I mean, I think you get this, right? It's like, so what solves the two-factor authentication problem? 3 factors, 4, 5 factors? Are we getting there? No, the same attacks will work. It doesn't really make any difference how many factors.
So Robert was describing to me how he's going to stand up Internet 2.0, not Ajax,
right.
seriously, like another internet that's secure, because this one sucks, right? And he said, well, you can't run another wire to every house, so forget about it, right? He says, no, no, no. We're going to create a new network, and you're going to log into that one, and then you're secure. And I'm like, so you're going to authenticate people into your security system so that they'll be secure. And it's like, yeah, how are you going to do that?
Yeah, that's not going to work, right? So you cannot solve this problem with more of what caused the problem in the first place, right? So I say we get this, I think intuitively we understand this, right? So, so how do you solve the hijacking issue, right? You guys know what this is, Kanye West, all right? It's like, I think I'm just going to hijack your talk. So in order to prevent this, right, you're probably going to have to be doing something different, right? So one of the things that you want to do is you probably don't want to be doing authenticating a session, right? You want to authenticate a transaction. You probably don't want to have a session where you have multiple transactions occurring simultaneously, right? So it's like Ben logs into his bank and he wants to pay his bills online. So he pays his Visa bill while at the same time I'm transferring money to, the Cayman Islands as the attacker, right? So the fact that we're allowing an authentication session where multiple transactions can be occurring in the foreground and the background at the same time, that's probably part of the solution is going to involve no nesting, right? And these are sort of some of the ideas around how you're going to get past these session hijacking or me coming in on your session and do some of these things. Go ahead. So that's a little discussion of where we all are today, right? Everyone here, I think, gets and understands multi-factor authentication. That's what you guys know, but that's not what we're supposed to be talking about, right? We're talking about the future state, and the future state is about adaptive authentication. And if you're using adaptive authentication right now in your enterprise, in your organization, good for you. Not very many people are.
Bob wants to see a show of hands. He's curious.
Sure.
Anybody?
No one's using adaptive authentication. Who's using multi-factor? All right, so multi-factor, clearly you guys get that, right? We have that in the organization. If you don't have it, you've either made some decision it's too expensive or it's not going to solve the problem anyway. But adaptive is where you guys should be going over the next 3 to 5 years, right? And if we ask the same question in 5 years, I expect adaptive is going to be where everyone who's running two-factor authentication is going to be running adaptive 5 years from now. So anyway, so that's where we're going. That's your future best practice. So what's adaptive, right? Adaptive is about looking at a authentication as a transaction, and we're going to make a risk-based decision about that transaction. So it's now not about level of assurance, right? But we're using level of assurance to allow us to determine whether or not the risk of this transaction is worth it for the organization or enterprise that's about to give you either access or not give you access. Go ahead. So the first thing so we're going to talk a little bit about the pieces of adaptive, right? The first piece of adaptive is a concept of dynamic scoring, right? You want to log into a system or you want to transfer money, you want to do a transaction that is going to require some authentication. I need to score that transaction. I need to assign that transaction a risk score. And the thing that you need to know about that is that risk score is going to be dynamic, right? It may or may not be the same every time. So on Tuesday morning, you log into the server and you get, I'm going to give that a risk score of 12 because we're having a good day. That evening, Tuesday evening, I'm under cyber attack from China, right? Let's say hypothetically I'm Bank of America. I come under cyber attack from China and accounts are getting hacked, right? My risk appetite is significantly decreased at this point, right? I want to shut stuff down, right? I'm going to start turning off services, and I'm less concerned with providing customer service and with making sure that everyone can do stuff. I'm more interested in fighting off this attack, right? So I just lean on that risk score. It's like risk score is now 24 for logging in. So it applies to the environment as well, right? So it's not only the transaction of the thing that you're doing, right, but my risk appetite in terms of what I know about the environment. It could be a big malware attack, Could be a variety of different things, right? So anyway, in addition to the things that you're doing as a customer might be different. Go ahead. Right, so obviously I'm going to need a risk engine, right, that evaluates risk and then pairs that up with the credentials that you've provided to me, right, which make me feel more comfortable about this transaction or increase the score of the credentials that you're giving me or don't, right? Go ahead. So if we think about it in this context of password is something you know, biometric is something you are, a long key or a token or a fob or something like that is something you have. We're going to describe adaptive authentication on that list as something I know, right, as the enterprise, right? So the password is something we know or we share. Adaptive, something I know as the enterprise. So I'm going to combine the something I know is the context that this transaction is occurring in, right? So what's going on? Hit it. So what are some of these things, right? We're going to take into account the overall riskiness of the environment. Is this to gain access to a group of apps or just one app? What kind of score do I need to get? And it's sort of these multiple credentials that may be passed and the sort of level of assurance of those. Go ahead. And largely what we're looking at is context as a factor, right? So the context of this transaction, the context that this transaction is occurring in is the other factor, right? So we're going to look at what time is it, right? Where's the location that you're coming from, right, on the network? And is that location spoofable, right? IP address I might be able to trace back to a location, but with very low confidence, right? Cell tower, if I have access directly to the cell tower that you're coming from, much higher confidence that can't be spoofed. Or are you reporting it in terms of GPS? Very spoofable. It's just, I'm just making up some numbers. The device, what type of device are you coming from? Are you coming from Android, the most exploitable platform on the planet? Or are you coming from iOS? Right now, much less exploitable, right? I might have more or less confidence in the platform. Browser fingerprint, right? Almost a unique identifier, right? Have I seen this particular browser fingerprint before? Were the transactions from this browser fingerprint good last time or not so good? What platform is it? MAC address, network, that type of thing. You want to speak to this one?
Yeah.
All right, you do it.
So that's adaptive, that's forward thinking, right? Did anybody get anywhere over the challenge? Any ideas?
Figuring out how to.
Don't cross the tripwire. I think it starts firing automatically, right? Nice, well done. DMZ over there, okay. Anybody got any ideas how you're going to right now provide
authentication in a hostile network?
Level 4 authorization and authentication and auditing to level 4 with what you got within reach. Right? So everybody is sitting on a cryptographic device.
No.
GPS, no. Cryptographic device. What does it do? It has a private key. It only has an interface in which you can pass data in. It transmogrifies that data with a private key, and then it puts data out, right? Credit card. Well, you've got these PIN chip cards.
Right. Chip and PIN, which you have in Europe, does. I have one of those.
I've got an
also
Oyster
have
card, too.
the US card, no chip, right? But yeah, that's a cryptographic device.
Right. So the Oyster card is also cryptographic. Anything else?
There you go.
SIM card, right? But the advantage of the SIM card is that it's connected to an electronic circuit, including a battery, transmitter, and a display. Your credit card, unfortunately, does not have any UI, unless you've got something I don't have. So, which you already do, because I'm an American and I don't get chip and PIN, even if I go to the bank and say, please, I'm traveling. They've never heard of you, by the way. Start a war or something, I don't know, they'll listen. Yeah, how'd it go? No? Okay. So what do we've got a chip card. Now, The one that I found was, in fact, the SIM card. It's that the old ones are bad, but the new ones are proper cryptography, meaning that the secret inside is not accessible from the electronics. Is that enough? Your machine is totally owned, right? So you can go in and put in a code into your SIM card, get a response back, and your phone company can actually verify that that number, or whatever token we started with, was in fact manipulated by your SIM card. Hands down. There's no problem with that. The problem is that if I own your phone, so can I. Right? So we've got to go a little farther than that. Robert and I, he does this professionally, right? He gets scenarios and he explains, based on cryptographic primitives, why that won't work, et cetera, et cetera. So he asks a simple question like authentication, right? Like, so I come up with various ideas and he shoots them down, just like that thing. So I've got welts all over, but I did get through, right? So in the end, we managed to find a way. One of the axioms that kept cropping up as a theme in the solutions that worked better than the ones that didn't was networks are hard. So it's pretty hard to stand up a network. If you own the cell towers and you're getting information about the users, where they are, for example, it's pretty difficult to spoof that. If you're listening to the device to tell you where the GPS says it is, well, I can emulate that in a computer without any problem at all. So the network is pretty difficult. I expect that in the future, cell phone towers, cell phone companies, device manufacturers like Apple and Google, and various things that have a pretty prolific footprint will be in an advantageous position to provide security as a service. And I would expect consumers to be, getting their first-class security through their providers.
And I can't fake what cell tower I'm connected to, right? So right, if I ask the phone, what cell tower are you connected to, and I've owned the phone, right? So I'm the attacker, and let's say you're the service provider, and you ask Ben's phone, what cell tower are you connected to? I, as the attacker, can tell you whatever I want. Same thing with GPS. So no, right? So if the bank asks Verizon, what cell tower is Ben's phone connected to?
That's right.
So on the previous slide, I put locate, right? So location. So there's a company called Locade that is doing exactly that for the big vendors, right? So that relationship does exist. It's very expensive. It's only something you'd expect to see for the big enterprise players like a Bank of America, Citibank, big medical, the defense contractors, et cetera. But they can do that, right? Now, and so what we're saying is, in terms of networks are hard, that's what they should do. That's really valuable security information. And Verizon is in a position, or Verizon, AT&T, all of the big network providers are in a position to tell you, to provide this information. So as for instance, an IP address, right? You query an IP address, you query the device, you get my IP address, we all know that. You don't really know exactly where I am, okay? But my ISP does, right? So people who have big infrastructure networks, right, with a physical footprint are in a position to provide some very interesting information on a transactional basis, right, and earn a fee. They can provide that information back out to players. And obviously, they're going to provide it back out to the big enterprise players right now. No reason why Verizon should not be selling that service, or Comcast or anyone else, of linking that final step to physically where are you right now. So you could get there.
So the persistent problem, even if we solve this and authenticate that this is in fact the device that it says it is, we don't have non-repudiation. We don't know for sure that the transaction that's being proffered is the transaction that the user intends to proffer. Because if the phone is owned, there's man in the middle, anything he says that he intends to do can be reinterpreted to the bank and re-expressed back to the user. So it's really insufficient to have this notion of an authorized session because it tells you so very little about what you're about to do. So in the case that we have a relationship with Vodafone and we have a security signal coming back from the device, that really gets us nowhere unless we combine the transaction details with the authentication.
Are we ready?
No, we've got two more, actually, unfortunately. This is a long slide.
Go ahead.
So we have to think about the combining of the transaction and the authentication. If there's no way to use the cryptographic primitives in a hostile environment unless you do so.
So this is the no nesting thing, right? You don't want two transactions to be occurring simultaneously.
Well, yeah, related to that, right? One authentication per transaction. It's more complicated than that. The transaction has to be conducted almost largely in plain text. If you secret the transaction, it can be spoofed. The user has to understand the transaction and has to express it fairly plainly. It's difficult to make that secret and still operate effectively.
Right. So I want to reiterate that, right? You don't want that transaction to be occurring in the background and say, the bank says, all right, I got a transaction, now I want you to authenticate this thing over here, right? That you want the authentication to be right there next to you're authenticating that this is what you want to do, right? Right? Confirm, and then you put in your authentication, right? So we want that all the details or enough of the details of that transaction to be presented to you that somebody who's attacking, right, can't get in that.
So the SIM card on the phone is good, but it's not good enough. As it is, it's completely useless. An owned phone can just use it, right? If I own your phone, I can just use the one that's on your phone. I send your phone data sends your SIM card the data that I send it, and it sends me back the reply. This doesn't buy us anything. We have to have an independent user interface on the SIM card. We could put a display and a keyboard on it, but that's a little ridiculous. As a practical matter, you have already an accelerometer on the phone, not a good place for it. If you relocate the accelerometer into the SIM card and make it available only through the SIM card, then the SIM card can independently verify what's going on the phone. Probably with reasonable accuracy, understand what is being typed into the keyboard. So you can duplicate the existing user interface into the SIM card directly in a manner that can't be spoofed, can't be piggybacked, and is basically not available for applications running on the phone to interfere, man in the middle, and the rest of it. So you've got to get access to that crypto device to the user. This is a one-way UI. You can only type data into it. The data you get out will have been cryptographically signed by the SIM card. As a consequence, you can either report good data or not report it. There's not much you can do, man in the middle, on that returning data. So that's probably the most practical solution that we've come up with that Robert didn't shoot down a million times. So the other one that's on the bottom, I called it premium URL. In the US, we call it 900 URL. We have phone lines. If you call a phone line, you have to pay some money. If you tie a financial system to certain URLs so that when you log in, you have to pay some small fee, like 1 penny, and the ISP is responsible for collecting that upstream all the way back to the origination point, you create a scalability problem for people who want to brute force logins. So we don't have to dwell on that, but that's a workable alternative or tool for avoiding the scalability problem, because people who have lots of bandwidth can type lots of passwords.
So another part of adaptive authentication is heuristics. we're using context as a factor. And one of the pieces of context is information that we know about this transaction, our experience with this transaction. So I may look back and I say, well, is this transaction from a user that we've seen before? Does this transaction fit with the pattern that that user has displayed in the past? And we broke this down into two categories, right? Group heuristics and personal heuristics. So there's things about this transaction that may be common to that user if they're good, right? Here's a transaction that is similar to transactions that this user has done in the past, right? But there's going to be transactions, like when I buy a car, right? Which I don't do that often, right? But it is an expected transaction that you would expect somebody like me at some point in time is going to buy a car. And it is off the scale, right? A one-off, right? It's a huge amount of money going to a vendor that I've probably never purchased from before, right? And it does not fit with the current pattern of purchases that I would make, or any other pattern that I would have, right? But what we do know is that as a group, that people like me do buy cars occasionally, right? People who have jobs, salary, live in the suburbs, have kids, married, blah, blah, blah. These people buy cars. So it's not that unusual as a group to see a purchase of a car, even though it would be very unusual for me as a person, right? So you can look at heuristics and experience in that context, not only from the perspective of things that you have done in the past, but things that people like you have done in the past. Probably, if you're using that, though, you want to consider both of those, right? So right now, your credit card company will typically reject your credit card transactions based upon group stuff, almost exclusively. They don't look too much at the personal stuff. So if I drive, I own a beach house in Delaware. If I drive to Delaware and make a purchase, that looks like my credit card has left the state, right? Even though this particular state is a state that I go to frequently, right? And my credit card company, if they're looking at my personal heuristics, should know that I go to Delaware. They don't. So anyway, so we wanted to talk a little bit here about some other stuff that's related to this topic. Not only adaptive, but sort of authentication, just so you sort of see where some of these other technologies fit into the puzzle. So CAPTCHA is really not an authentication protocol, right? This is a Turing test of whether or not I'm dealing with a script or with a human. Wow, that went quick.
No, it was up there for 5 minutes. You went on and on and
That's right.
on
Blah, blah,
about
blah.
the damn car.
Stop talking. Get that gun out. So another two things you've got is a federation and tokenization, federation and tokenization. So there's a variety of different protocols here that we can use to basically, I can outsource my authentication, right? As you come to my website, I don't want to maintain all that infrastructure, and I don't want to maintain hashes and deal with password resets. So you can just log into my website using Google, right? And I'm just going to assume that everyone who logs into my website has a Google account, which is probably a pretty good assumption. I can just outsource that with, so that's OpenID. SAML is a way.
So this strategy is called creating even higher value targets, right?
Right, exactly. Let's centralize all the authentication into one company. SAML is, let's say, Bank of America has a contract with Booz Allen, right? And we've got a bunch of Booz Allen consultants coming in. We don't want to recreate all of the records for all these Booz Allen credentials. We don't want to recreate them in Active Directory of Bank of America. We just want to leverage the Booz Allen, what they're already doing, right? So I'm going to do a SAML federation. I'm basically going to attach Bank of America's authentication for those Booz Allen consultants by XML to the Booz Allen open Active Directory, and that's SAML, right? And then Kerberos is basically, so on Bank of America, I run 500 internal websites for employees. Every time I, as an employee, switch from one website to another, I used to work at Bank of America, right? If you haven't gotten that already. As I switch from one website to another, I don't want to have to log in every single time, right? So if I create single sign-on, basically I log in one time in the morning, I get a token that says I'm logged in, and every website within the enterprise will recognize that token because they can all check Kerberos that it's a valid token, and then I don't have to log in anymore. And token expires in 24 hours. And OpenAuth is basically a way of doing that same type of thing. So that's authorization, not authentication. Basically, it's a way of sharing who's authorized to see what. Go ahead. So we've ended up with talking about sort of how we're going to do authentication in the future, how we're going to move from where you guys are, which is multi-factor, into adaptive, which is sort of the next coming thing. But obviously, adaptive doesn't really solve the problem, right? It's at least a different type of factor. So it's a good place to be 3 to 5 years from now, but it's not going to solve the problem that we posed at the beginning, which is how do you do authentication in a hostile network when I've owned your phone, and I've owned your laptop, and I've owned your desktop, et cetera, and everything you touch is already owned. So we wanted to throw out some ideas. Right, so the next couple of slides are basically, now through the end of the talk, ideas about sort of where things could be going from here.
No, we wanted them to throw out some ideas.
Well,
That's what we're
that
missing.
would be better, right? If you could do our work for us, that would be better. But here's what I want. These are the things I want you guys to be building
a pen,
on.
that's a good idea, right?
Right. I want you to be building on these things and coming back to us with actual technologies. So an intention dance is basically a series of actions that I would ask you to do in the physical real world, right? Maybe moving your phone around or shaking it, something that I as an attacker can't do to your phone, right?
So specifically shaking it, right? One of the things you can do with your phone is you can spell out in the air your intention and your signature. I want to send $25 to my friend Robert, signed Benjamin. You should do, yeah.
Accelerometer is going to capture this in 3 dimensions, right?
In the SIM chip, right?
Right.
Completely.
Sure. So first one, accelerometer, right, is moving the phone. Second one, I could physically move it to another cell tower, right? And if I, as the authenticator, as the server, tell you on the phone, it's like, I need you to go a mile north, right? And the phone goes a mile north, right? That's a pretty good demonstration of intention. Where you're going, another way is I'm going to need you to go to Piccadilly Circus, right? How many video cameras are there in Piccadilly Circus, right? Well, if you're an attacker, right?
When it's populated or when it's empty?
Because
I think the answer is like 5,000.
Right. So I was going to say, when it's empty, there are 2,000 cameras focused on Piccadilly Circus, right? When it's populated, a lot more. But if you're an attacker, you physically stole my phone, where you don't want to go, right, is the middle of Piccadilly Circus, right? You don't want to go where there's a lot of people and a huge number of cameras watching where you are with the device that timestamps you on the network as being in a particular place at a particular time and executing a transaction, right? A lot of risk in that. So these are things, we call it the intention dance. Think of it as sort of in that movie where they have to make the payoff for the kidnappers, right? So it's like, I want you to go to this corner and pick up the payphone, right? And then you'll get further instructions, right? Then I want you to take the A train to such and such a block, and then somebody, a bike courier drives up and gives you your next instruction, right? By the time you've executed these series of things, obviously the goal is to lose the police, but by the time you've executed these series of things, right, we're pretty sure that you intend to create this transaction. That's the point of the intention dance, right? But the intention dance has to not be a series of things that you would, 5 minutes? Okay. That you would do virtually on the phone, right? Because that can be spoofed. The physical world, you can't do it because networks are hard.
So one of the key components here is you have to imagine the user at the end of the day, you're going to ask them in court, did you do this? Did you intend to execute this transaction, right? If you can't prove in court that they executed this transaction, well, you really don't have a transaction to begin with, right? So non-repudiation means that you can prove that they intended to do this, it was them, et cetera, et cetera. So signing with your cell phone actually could be brought in, right? Because we can recreate those series of actions and express them as a line on a virtual piece of paper. Those kinds of things can be non-repudiatable. But a lot of other things can be a little bit difficult to interpret. I mean, even this crazy thing where you're driving around town, hopping on buses and so forth, runs the risk, in my opinion, right, of not being very explicit, right? You're doing a lot of crazy things,
Depends
but
on
yeah,
how
to
many.
what end?
Yeah, depending on how many of them are prescribed, right?
Right, but they have no intrinsic meaning
Right.
is a challenge, right?
Right.
So the transaction really needs to be plain text. It needs to be completely evident in court later that that is exactly and precisely what you intended to do at that highest level.
So a notary is somebody
You're going
who
to need these, by the way.
Yeah. So a notary is someone who knows me well enough that they, on the face of it, cannot be spoofed, and they know that this transaction is either very likely to be good or very likely to be bad. So the model of a notary, just as an example, is my wife, right? So last week, if Bank of America had called up my wife and said, somebody's trying to withdraw $300 from an ATM in London, my wife would have said, denied, right? And it's an insta-denied, right? She doesn't even need to know where I am, or she doesn't need to call me, she doesn't need to know. She knows I'm not in London, right? And this week, if you make that exact same call, right, she doesn't need to get in touch with me. It's an insta-approve on the exact same transaction because she knows this week I'm in London, right? She doesn't know why I'm withdrawing $300 from an ATM. Clearly, that's a little bit unusual. She wasn't expecting that I needed to withdraw $300 from an ATM in London. Well, that's true, yeah. But she knows that, right? And if you posited a transaction that was maybe somewhat more questionable, she knows exactly how to get in touch with me almost every time, right? There's a very high probability I'm standing right next to her at any given point in time. So very hard to pull one over on my wife, right? And use my credentials and get past her, right? And everyone has someone like that, right? I'm not saying that that's something about being married, right? It's just about having that intimate relationship that the other person knows you so well or knows how to get in touch with you is not, you put an attacker on the phone, the attacker is, my wife is not going to mistake the attacker for me, right?
So not only
instant voice print knows, she could bring up any challenge question that she could ask, I would be able to answer, and the attacker would not, right? So is a insta approve or disapprove from
So
my
from
wife.
a technical point of view, not only does everyone know someone else, right, but everyone else knows somebody else with a cell phone. And if that cell phone can also pick up these same signals, you can put two cell phones together, shake them, and prove, again, non-repudiation, that they were in the same place at the same time and intended to do this.
Right.
So the last one before we get shot off the stage is proof of work.
There's two more, actually. Keep going. So proof of work.
You got time.
Proof of work. Talk faster. Talk faster. Proof of work is a scheme where you have to put some effort into doing this transaction. It's not something where I can just hit OK, right? I may have to spend a couple of minutes of computer time to do it. Hit
Glasses on.
it. Right. Hit it. Assumption of risk. The transaction, from the bank's perspective,
Seriously,
is
dude.
fundamentally
Glasses.
risky. If I can pass some of that risk off, great, keep going. Hardware solutions. You can build hardware, build this into the hardware. Obviously, adding the accelerometer to the SIM card is a hardware solution. Intel's working on their next version of a chip. Will have a protected memory space for things like keys.
So that when I own your phone, I can also go into the protected memory space and manipulate them.
Right. Questions?
Loudly, from the back.
Q&A. Anyone have any questions?
If anyone's got a question, I've got a microphone so that we can hear you. Anyone with a question? Anyone with a question that's not, when are we going to shoot them with the Nerf?
Right.
Anyone? Question?
They look transfixed.
Right.
They see the inevitable.
That's right. Viz is hoping I stand here just for a couple more minutes. All right. Thank you very much. Appreciate it.